All right, everyone. This week is going to be spent as a kind of review and reinforcement of Chapter 7. You can expect the problem set is going to test you on all things. And next week, we're going to move on to Chapter 8. So let's use our time as wisely as possible. I am going to be taking 3 questions from the Chapter 7 practice test in the textbook. There are other practices that you can do, and I've also posted solutions of the previous work. Hope you're keeping busy and keeping, up to date. Please use this time not as a way to sort of take a break, but also more so just to reinforce and just have that confidence of being able to work that problem set with ease and efficiency. Question 6D in page 410 is going to be something like this. I had to reproduce the picture. If you're following through, you can open up the textbook now. You can pause the video. Starting off, the question simply asks, find the measure of each unknown angle in the diagram. I'm going to go further by saying, tell me how you know the answer you got is true. Basically, prove it using the theorems that we've learned in class. So here we go. I know for a fact that angle V is going to be 180 minus the 125, which is going to be 55 degrees. That is due to supplementary angle theorem. Okay, let's keep moving. In the same breath, angle W is going to be 180 minus 130, which is 50 degrees. How do I know that? Supplementary angle theorem. Moving on, same breath, X is going to be equal to 180 degrees minus 105, which is 75 degrees. Why? Supplementary angle theorem. If you are wondering what the heck supplementary angle theorem is, please go back and visit our, I believe, the early portions of chapter 7. It is basically when a straight line is equal to 180. So any two angles that create a straight line, so in other words, let's say, for example, 105 degrees and the x angle, we know that in total it's going to be 180 degrees. Okay. Lastly, angle y is going to be 360 degrees minus 55, angle V, minus 130, that's right here, minus 105, which is right here. Let me draw that out as a kind of a highlighter for you. Angle V, right here, angle W, angle 130, angle 105, and angle Y are all interior angles of a quadrilateral. What does that mean? That means all 4 angles together will add up to 360 degrees. Subtract the 3 pieces, I will have the angle Y left. That is going to be, please excuse my lack of mental math here, 105, 70 degrees. That's it. And then as a final breath, angle Z is 180 minus 70, which is 110, and that is supplementary angle theorem. I didn't officially introduce a theorem for this per se, but what you can do is simply say, you could even just, you know what? I think it's sufficient if you give me the formula of why you know 360 is the sum of the interior angles of a quadrilateral. You could say 180 times n minus 2, right? You can just give me that, and I know that you know what you're talking about. There you have it. That is number 6D. I'm sure there are a lot of other challenging questions that come your way, but let's keep moving on. Drawing a little line here to divide myself. There you go. Question 8. Question 8 says, draw a counterexample to disprove the hypothesis that all quadrilaterals with a pair of equal opposite angles are parallelograms. Just as a argument, a parallelogram is a quadrilateral where opposite sides are parallel to each other. What does that mean? Long story short, and just because we're arguing about angles anyways, the angle here, the top left and the bottom right, are going to be equal to each other, and the angles in the bottom left and the top right are going to be equal to each other. I need to give a counterexample to show that if a quadrilateral only has one pair, it doesn't mean that it's a parallelogram. And so here is my counterexample. I'm going to draw you a kite. Ready? And again, freehanding this is not the easiest. Okay, but let's assume that this side and that side are equal, and this side length and that side length are equal. So you can imagine it's, it's a kite. Okay, happy, wow, I suck. A happy child with a happy kite. Okay, so how do I prove that, how do I use this as a counterexample? Number one, is this a parallelogram? Sorry, is this a quadrilateral? Yes, it is. Number two, is it a parallelogram? No. Does it have opposite angles, one pair of opposite angles that are equal? Okay, pair of opposite angles equal. Well, being a kite, obviously you can eyeball and say this angle and that angle are not the same. Right? However, we can argue also that there is a line of symmetry, a mirror image between the left side and the right side for a kite, or even a diamond or anything along those lines. What does that mean? That means that the left angle and the opposite right angle being symmetrical, they're going to be equal. Again, is it a quadrilateral? Yes. Do they have a pair of opposite equal angles? Yes. Is it a parallelogram? No. Therefore, this is a counterexample to disprove the hypothesis that all quadrilaterals with one pair of equal opposite angles are parallelograms. Okay, that's all you need to do. And if you want to be very eloquent, you can have a therefore statement, writing that down. Let's write that in pen, in dark color. Number 10, the sum of an interior angle, the sum of the interior angles of a polygon is 2,340. How many sides does a polygon have? All right. Sum of interior angles equals 2,340. What does that mean? Well, from what I know so far, 2,340 is going to equal 180 degrees multiplied by n minus 2. Remember that from previous lessons? I hope so. That is the number of sides a shape has. Or it could also be the number of vertices. But anyways, if that is the case, what do you notice about what you just wrote? I have an equation with one variable. I think we can simplify this. Okay, so up until now, you may have been asked questions where I tell you how many sides there are. You plug in a number in the variable n, subtract it by 2, multiply by 18, and the final answer is to the left. Well, this is a very, very simple example of a question where I give you the answer and I ask you what the question would have been. So let's do some algebra, okay? Erasing this, we've got divide both sides by 180. That turns into 1. And 2,340 divided by 180 is going to be 13. Well, now that we don't need any brackets because it's not separating n minus 2 from anything, I'm going to add both sides by 2. 15 is going to equal n. This is a, oh gosh, I don't know the actual word for 15, shame on me, but this is going to be a 15-sided polygon. Okay, yeah. All right. Very simple questions, but honestly, even question 10, although it's under the extended responses section of the textbook, I really don't think this is beyond you. Please practice this. If you haven't done the Chapter 7 review yet, please do so. I also posted a bunch of questions that you can try and submit to me for formative feedback. You are responsible for the problem set that is posted in the Google Classroom. The due date, so homework, is practice questions plus, of course, the problem set. The problem set is actually worth marks. All right, please get this done. It is highest priority, and it's our very first evaluation worth marks during the COVID-19 time. This is going to be due the day before our next week assignment, which means this is going to be posted on Wednesday. It is due April 21st. That's a Tuesday. Okay. Please do what you can, butt heads with other people, argue, consult, do whatever you need to, ask me questions, email, whatever you need, but get this done. Super important. Best of luck and hope you're doing well. Hopefully see you soon. Take care.